Yeah, okay, so hi guys. My name is Nikita and I'm a software developer here at DataArt. And for more than 2.5 years, I have been involved in development, including serverless architecture and AWS Lambda. And today I would like to talk about Aurora Serverless, a new absolutely serverless database in AWS. So we'll first start with the simple Amazon Aurora, and then we'll come to Amazon Aurora Serverless in terms of internal structure, limitations, pricing, and so on. So what is a simple Amazon Aurora? Aurora was developed by Amazon on top of MySQL and PostgreSQL for cloud computing and was optimized for high performance and availability. It can scale using read replicas and multi-availability zone deployments. And if you want to create a cluster inside Aurora, you just go to AWS console. You need to specify the cluster size and instance type, and then you'll get everything done. At the same time, you can change your cluster in terms of you can change the instance type and the amount of instances inside the cluster. And this works well when you have a highly predictable load. But if you have unpredictable load, or if you are a small startup and you use mostly lambdas, which can scale up almost indefinitely, you'll have a problem with the spikes. Or if you have no load, you'll have a problem with over-provisioning and pay more than you actually can. So that's why on the August of 2019, Amazon has presented globally Aurora Serverless. And small spoiler, Serverless part actually has has servers. So why it's still called the serverless? The only reason is that despite having an instances, it still corresponds to every parameter we assume to be part of a serverless. So it charges you only for what you use on per second basis. You don't need to spend time on management or maintenance, and it seamlessly scales compute and memory capacity with no disruption to client connections. And as it's a part of Aurora service, it supports everything we had in Aurora. So how it works internally. In our Aurora Serverless, we have a proxy fleet and the amount of database capacity. So when you need to connect from your application, your connection goes to proxy fleet, and then the proxy fleet will redirect the connection to a particular database resource. At the same time, your serverless service has a warm pool of database capacity, so AWS is ready to add or remove database resources from your cluster. And when the scaling happens, you don't need to worry about the client connections because the proxy fleet will do everything for you. So if Amazon removes the database capacity unit, the proxy fleet will redirect your connection to another database storage. As we know that our Aurora Serverless is a new service, it has a lot of limitations. For example, it's compatible with MySQL 5.6 only. You should use only the default port of MySQL. It's accessible only from within the VPC, so you don't have a public access. You also cannot access Aurora Serverless from AWS VPN. So you just need to create a Lambda or EC2 service inside the same VPC. You can modify only 5 internal MySQL variables, and if you try to modify any other variables, you'll get a permission error. And despite being a part of Aurora service, it doesn't support such nice things as loading data dumps from S3 bucket, which is really useful when you have a lot of data. It also cannot invoke AWS Lambdas from inside the MySQL functions. For example, you cannot invoke AWS Lambda from the trigger, and it doesn't support read replicas. In terms of pricing, Aurora Serverless pricing is based on the ACU, which is like read the capacity unit or write capacity unit for DynamoDB. And one ACU is approximately 2 GB of memory plus additional CPU and networking. And in this table, you can see the comparison of serverless price, the price for serverless cluster and for provisioned cluster. And you should pay attention that your serverless cluster is deployed in multiple availability zones by default. So here we compared the price for multi-availability zone provisioned cluster. And you can see that the serverless version is a bit cheaper. And it's better for companies which need to spend less money on your infrastructure. And also you can see that there is no row for 4 ECUs. This is why, because 4 ECUs corresponds to T2 large instance type, and this instance type is not in Aurora Serverless documentation, so we cannot compare the price. In terms of auto-scaling, it scales automatically, but you need to reach particular rules for scale up and scale down. So for scale up, you should reach one of the rules. Your CPU should be above 70% of used, and you should use more than 90% of connections. And the cooldown for scale up is 3 minutes. And for scale down, you should reach both of rules. So your CPU utilization should drop below 30%, and you should use less than 40% of connections. And the cooldown for scale down is 15 minutes. So if you have a spike, your cluster will have time to be scaled up to wait for another spike in a short period of time, because it won't be really convenient if your cluster will scale up and scale down frequently. No, they're fixed by Amazon, so you can change it. Yeah, so talking about maximum connections, AWS uses this huge and ugly formula for max connections. And in the table, you can see the corresponding max connections value for different ACUs you can use in your cluster. And during the investigation of Aurora Serverless, I've decided to not to track the response time, because inside Aurora there is inside Aurora Serverless there is a simple Aurora, and it will have the same time to response. At the same time, we decided to track the time needed for scaling, and the script was done to track how much time our cluster will need to change the maximum connections value, because it's actual trigger that you will have access to the new database capacity, and the time to capacity is actual time your cluster need to change the max connections value, and time to completion is the time when the AWS console show you that your scale up or scale down was done. And as you can see, the time for scale up is approximately 1 minute, which is kind of good for most of scaling, because our CPU and memory for databases grows twice every time, so it will be enough to prepare your database for a huge load. In terms of monitoring, you can use CloudWatch, and CloudWatch gives you a lot of metrics, the same metrics as you have for a simple Aurora, but the one metric is extremely interesting. It's serverless cluster capacity, and you can see the plot on the slide. And this metric helps you to understand how much time your cluster needs to scale up. And also you will see the performance time, and you can create a nice alerts of spikes for your cluster. Also, in the November of 2019, Amazon has created Aurora Serverless Data API, which is, according to Amazon, a nice way to connect to Aurora Serverless using HTTP. At the same time, it's in beta, so there are a lot of limitations too. It's available in only one region. There is no description or example in AWS guide, and it has no IAM role-based access, so you need to keep your secrets in AWS Secret Manager and then use it for your connection. And if you try to compare the access to Aurora Serverless through VPC and through this data API, you will see that the access through VPC blows up the access through HTTP in terms of response time and response size. So it's not really convenient for you to use the data API now. And it still uses SQL queries as strings, so there are no prepared statements, which is actual security problem. So I hope that sometime Amazon will fix it and prepare the better way to access to our serverless. And to summarize all above mentioned, Aurora Serverless is a nice, new, impressive service. There are a lot of limitations now, but Amazon might fix them later. It solved the common problem of over-provisioning because you don't need to set any cluster type, cluster instance type, or amount of instances in the cluster. You just need to set a minimum and maximum ACU per cluster. And we can carefully start using it in production. But as it has a lot of limitations, we need to think a lot about using it. So that's it for today. If you have any questions, you're welcome.